Hi everyone, my name is Pedro Pais, and I will be presenting the work we have been doing towards creating our living framework for understanding cooperative games. Playing games together has been associated with multiple benefits, from strengthening social bonds to promoting social interaction, trust formation, pro-social behavior, and also forming and maintaining friendships. And while the outcomes of a game's design are also tied to a player's idiosyncrasies and their context, understanding what design decisions are more likely to create the experience we seek will make our design choices more purposeful. However, previous efforts to systematize cooperative game design often lack methodological details, relying on informal procedures, with the latest attempts almost a decade old. And so, to be able to transfer generated knowledge between different types of games, we need to be able to provide a rigorous definition of a game's artifact. Even with the latest efforts, it's still hard to really differentiate different designs from each other. For example, how is the collaboration different in these games? Both have similar mechanics, but the way players collaborate is different. In Portal 2, each level has many tasks dependent on each other, but there's little time pressure. In Left 4 Dead 2, many of the scenarios ask players to reach the end while pressuring them with waves of enemies in regular intervals of time and limited numbers of resources, such as healing items or ammo. With this work, we aimed to extend past attempts at understanding cooperative play by developing a comprehensive framework supporting a shared terminology for description and discussion of game design structures, and also supporting knowledge consolidation and extension by the community through an implementation of the framework as a web app. I will go over our methodology now, starting with our search strategy, which we carefully designed aiming to gather a list of relevant cooperative games to analyze, our selection process, where we attributed individual games to 7 researchers, our analysis process, and how the framework was reviewed and validated. Initially, we identified the top-rated cooperative games from Metacritic and Steam. For Metacritic, since there was no specific category for cooperative games, we manually selected games based on keywords such as co-op or collaborative from the descriptions. We selected the top 10 games from each year between 2017 and 2022. On Steam, we leveraged the tag feature, looking for tags related to cooperative play, such as co-op, online co-op, and local co-op. We manually assessed and filtered out games based on the prominence of the cooperative tag and excluded duplicates that were already selected from Metacritic. Next, we assigned games to coders, ensuring they were familiar with the games they analyzed. Here, our approach was inspired by template analysis, a form of thematic analysis that promotes hierarchical coding, seeking a high degree of structure and flexibility to extend dimensions where the data is richer. After an initial coding template is defined, it is applied to the data, iterating as much as necessary, and finally, it also recognizes that a template is never truly final, and further engagement with meaningful data might extend the template. So, the analysis process involved reading store descriptions and reviews, as well as watching video reviews and playthroughs to ensure thorough familiarization. Coders used a template that included fields for general game information, multiplayer modes, and also pre-identified codes from related work. Each code had a space for observations, and there was also room for proposing new codes. Through multiple discussion meetings, we iterated through observations and proposed codes, resulting in the first draft of the framework. This draft was then reviewed by 2 additional researchers who analyzed 9 games with the framework, and by a final researcher who was involved in the last iteration of the framework. This brought us to a total of 129 cooperative games analyzed. And so, we get to the current version of the living framework for understanding cooperative games, with 4 high-level categories. I will go through each of them and illustrate some of their subcategories with examples. Play structures groups the categories that define the overarching structures of play. It includes how the game structures its progression, group formation, and goal structure. Player context groups the categories that shape how individual players engage with the game, and includes player identity, relationships between player entities, worldview, and also player view. Forms of cooperation groups the different forms through which games support cooperation and includes arrangement, synchronicity, how communication is expected by design, and the means through which players communicate. Lastly, we have cooperation design patterns, which includes the dimensions from the previous categories we construed as conducive to cooperation. divided into play structure, player context, dependencies, affecting others, resource sharing, asymmetry, and relations between players' actions. Now, let's look at the forms of cooperation category to get a better idea of how some of these values are defined. Specifically, let's look at arrangement, which describes how the game assigns cooperative tasks to players and how these are related. Task arrangement is called strict when the game assigns specific tasks to players. For example, in We Were Here Together, the cooperation happens as it is scripted to happen, with one player typically interpreting and transmitting information while the other one acts with that information. Task arrangement can also be free, where players can take on available tasks as they wish and decide how to contribute. One example is Lovers in a Dangerous Spacetime, where players collectively control a spaceship and can assume the control of the station they wish. Tasks can also be coincident, when players are accomplishing the same task together, as in Cuphead, where players have to shoot the same enemy boss until it is defeated, or coupled, where players take on different tasks that somehow intertwine and typically contribute to a shared outcome. For example, in Sea of Thieves, navigating the ship requires coordination with the gunner to align the shots. Now, how would the framework be used? Let's look at Overcooked again to exemplify how it can be used to describe a game's design. So, Overcooked's progression structure is party, as a whole group progresses together. It has party creation in group formation, because the group needs to be formed before gameplay, and a shared goal structure, as the goal of the game is shared. In player context, Overcooked has a single and distinct player identity representation, as each player controls a single entity and does not share it with others. It also has arbitrary selection, since character selections are purely cosmetic. It also has static progression, since a player's abilities does not change. And the players are individuals in relationships because there is no particular mechanic rooted in their relationship. Lastly, it has a shared game world and a shared player viewpoint. Here, as I mentioned before, Overcooked has a free task arrangement with sequential and concurrent asynchronicity, as players decide which tasks to take, and some tasks need to be performed in the correct order or at the same time. Communication is incentivized for coordinating, but it is only supported through emotes. In cooperative design patterns, Overcooked has group progression, shared goals, and shared player viewpoints from the first two categories. It also has task dependencies as well as spatial, as in some levels players are placed in separate parts of the level. Also, scaling difficulty as the target score increases with the number of players. In resource sharing, Overcooked has consumables and interactables, as players have to share the food items and cooking stations, and also space, as players block each other's movements. We wanted to ensure our framework did not remain a static resource and instead supported integration of new knowledge, so we deployed it as a web app designed to be easy to access and interact with, as well as expandable and reusable. With this in mind, we implemented an interactive view of the framework and authoring of game reports and framework extensions. In the interactive view, users are able to explore the most up-to-date version of the framework, where they are able to select different values, read their definitions and examples, which are created by the community through our reports feature. When extending the framework, users are asked for a new title and description and are then able to add or remove new values or categories. This version of the framework is then saved to be later reviewed or used in a game report. To create a game report, users go through a guided process where they select the version of the framework they want to use, which could be LFCG or a community version. They search for a game to report on, where we leverage IGDB, the same database that Twitch uses for identifying games. They could provide additional details such as game mode, the level and modality of analysis, and then identify existing or relevant values with fields for observations and also linking media, and lastly, details on the method of analysis, game familiarity, and difficulty of use. Each report can be selected as public, adding to the collection of reports already existent, which are then aggregated in the website for review by others, populating the list of examples for a given value. With our framework, it is possible to define and control game design variables and account for covariates, allowing us to design studies that explore complex design choices. We are committed to identify not previously explored promising categories and understanding their role in shaping cooperative experiences, particularly in regards to player enjoyment, autonomy, and connectedness. Feel free to read the paper for more details and reach out with any questions. Thank you very much.